Hello everyone. Today I will tell you how to make a simple engagement ring in Nomad Sculpt. First, we need to create the gemstone. To do this, let's add a UV sphere in the sphere settings. We need to set the resolution to 8x2. Press validate, and I will also enable finger display on the screen so that you can see better what I am pressing. Let's switch to the front view. Take the cell mask tool, then choose the rectangle. Now select the lower part of the UV sphere, and using the gizmo and pivot tools, move it downward and compress the upper part. I will change the matte cap to white and continue working. I clear the mask and enable the wire display. Now I go to multi-resolution, uncheck keep triangles, and check linear subdivision. After that, I press subdivide, then move to the MISIC section, set the target triangle's parameter to 100, and click decimate. I enable radial symmetry along the y-axis with a value of 8. Using the mask tool, we mask these polygons. Then we invert the mask, take the gizmo tool, and raise the polygons upwards. After that, we clear the mask, mask these parts of the stone, invert the mask again, and lift the polygons upwards. Clear the mask again, mask these bottom parts, invert the mask again, and move them upwards and slightly to the side. You can also clear the mask by pressing clear here. Now we select this set of polygons and invert the mask. You can also invert the mask by clicking the invert button in this menu. Next, we choose the gizmo tool, pull the polygons up and to the sides, and then clear the mask. We'll raise the spike of the stone a bit higher. We mask it, invert the mask, and use the gizmo tool to lift our spike. Clear the mask again. Now we select these polygons, invert the mask, and using the gizmo tool, spread them apart to create a beautiful gemstone. Clear the mask again. The work on the stone is finished. We'll raise the stone a bit higher. Let's add a cylinder. Since the stone is 6 millimeters, the cylinder's radius should be 3 millimeters. We'll lift the cylinder higher. To scale the stone, we'll use the cylinder as a reference. Now let's work on the cylinder. Add a helper cube here with a size of 0.8. Roughly position the cube beneath the stone. Select the cylinder, then enable the hole option in the cylinder settings. Adjust the cylinder's position to fit it under the cube. In the cylinder settings, increase the polygon density. Clone our cylinder and using the gizmo tool, move it slightly down. Adjust the radius and thickness of the cylinder, aligning it with the cube. Let's increase the polygon count on these cylinders and add the post subdivision parameter. Press validate on these cylinders. Lower the upper cylinder a bit down, like this approximately. Next, we'll work on the prongs. For this, we'll use the tube and path tools. Set the diameter to 0.6, tube topology to 5, and post subdivision to 4 for rounded edges. Let's see how it looks. Adjust the tube a bit by scaling it up. Using the cube as a reference. I think this should be enough. Press validate and add repeaters, radial to the tube. Set the value to 6 along the y-axis. It looks quite good. Press validate. Join children. Yes. Move the helper cube aside. Lift our construction higher. Next, we need to add a cylinder, which will be the size of our ring. Rotate it using the gizmo. Set the binding to 90 and rotate it. Since our ring size is 18, the radius parameter will be 9. Scale it along the sides. Press 3 points and in the appeared menu, increase the post subdivision parameter to 4. Press validate. Next, we will add a UV sphere. Also rotate it using the gizmo with a binding of 90. For the UV sphere parameters, let's increase its size arbitrarily. We will adjust its size later to fit the ring using the helper cubes. For now, set the values along the x-axis to 18 and along the y-axis to 10. Using the gizmo, we compress our sphere. Next, with symmetry enabled, we work with the cell mask, and gizmo tools to give the ring its desired shape. To do this, we mask the polygons, invert the mask, and move the polygons as needed, adjusting the sphere to fit our desired size. We add helper cubes to guide us in setting the thickness. In the material settings of the sphere, we can choose the blending mode and decrease the opacity to see through the sphere. This will make it easier for us to control the thickness of the ring. We have a cube at the bottom of the ring with a size of 1.2. We will add another one with a size of 2. We adjust the ring, aligning it with these cubes as references. We can also use the measure tool to control the dimensions and ensure accurate sizing. Keep refining and adjusting the model until you are satisfied with the result. Don't forget to save your progress regularly to avoid losing any changes. We increased the multi-resolution for this part of the ring. We can now remove the helper cubes since we no longer need them. Let's position our gemstone with the prongs as we like. I like it this way. We scale the prongs along the y-axis and position them under the gemstone. Additionally, we'll increase the lower cylinder's size along the y-axis and place it accordingly. As far as I can see, it looks good. Next, we need to create cutter to carve out a setting in the upper cylinder so that the gemstone fits smoothly. To do this, let's add a cylinder with a radius of 3. Position it near the gemstone. Enable the transparent view for it. Mask the upper part of the cylinder where the girdle of the gemstone passes. Using the gizmo tool, reduce this part of the cylinder, aligning it with the gemstone. Then increase its multi-resolution. To create a setting for the gemstone, we need to hollow out the upper cylinder using the cutter. First, we hide the visibility of the cylinder and make the cutters visible. Then we select both objects and use the voxel merge function to perform this Boolean operation. This will result in the upper cylinder having a hollow space where the gemstone will fit snugly. Let's add a cylinder to create a hole in the ring. Using the voxel merge function, we cut the hole in the ring. Then, using the same function, we merge all the ring parts, excluding the gemstone and the cylinder responsible for the size. With the same function, we cut out the size of the ring. Our ring is now ready. We can smooth out the connections and edges with symmetry enabled along the X and Z axes. For 3D printing, this mesh might be too hot, so we need to optimize it before sending the file for 3D printing. The decimation function can help with this. Set an appropriate value, usually I use 20, and press Decimate. Check if the resulting mesh suits our needs and adjust the value if necessary. If everything is satisfactory, we can export the file in STL format for 3D printing. But we won't do that. Instead, let's go back to the dense mesh and render our ring. We'll adjust the materials and set up the gemstone. In the gemstone material settings, we need to switch to reflection. Increase the index of reflection. This value varies for each gemstone, and I'll set it to 2.4. But for precise values, you can refer to the link in the description to see the index for different gemstones. Don't forget to enable the two-sided parameter. We choose the color of the gemstone. Set the roughness and metalness parameters to 0. Press Force Paint All. I created this environment in the Keyshot software and now use it in Nomad Sculpt. We'll color the ring in silver. We choose a light gray color very close to white, set the roughness parameter to 0.2 and the metalness parameter to 1. Press Force Paint All. In summary, we'll adjust the materials, the scene, and post-process, and then we'll render the final result. That's all for now. Thank you for watching till the end. If you're interested in seeing more of my work, feel free to visit my Instagram. The link is in the description. Farewell and see you next time.